Numerical descriptions of data. 1. Measures of center. Central tendency. The mean, which is denoted with x bar, is the sum of xi all over n. So it's the sum of all the x values divided by the number of x values n. This is on the AP formula sheet. Sigma is known as sum, and x bar is the notation for the sample mean, the mean of all the numbers in your sample. We say the mean is non-resistant, vocab word you need to know because it is sensitive to every score. You will use the mean to describe the center of the distribution only when the shape of the distribution is fairly symmetric and no outliers. Median. Also, you'll see that median could be denoted with a capital M. This is the middle number of a distribution, also the 50th percentile or the second quartile. The median is resistant, another vocabulary word you need to know, to extreme observations. This means it isn't sensitive to every score. The median is a better measure of the center of a distribution when you have a skewed distribution. Pictures of distributions, shapes along with mean, median, and mode. So when this is skewed to the left, or negatively skewed, the mean and median are on the left of the mode. So here's our mean, our median is to the left of the mode. When it's symmetric or zero skewness, the mean, median, and mode are the same, directly in the center. And when it's skewed to the right, or positively skewed, the mean and median are to the right of the mode. Two, measures of spread, dispersion, and variability. First, we have the range. The range is the largest observation minus the smallest observation. This has to be a number. Next is our interquartile range, also known as IQR, which is the third quartile minus the first quartile. This measures the distance between the first quartile, the 25th percentile, and the third quartile, the 75th percentile. It measures the spread of the middle half of the data and it ignores lots of information about individual data points. We will talk more about this when we get to box plots. Standard deviation. This formula is on your formula sheet. Standard deviation. The standard deviation is just the square root of the variance, and we'll talk more about variance in a moment. X minus x bar is known as the deviation, the amount by which an observation deviates from its mean. N minus 1 is known as the degrees of freedom. You can think of this as a correction factor because we don't have information on all individuals in the population. We're taking a sample. We talk about degrees of freedom again next semester. The standard deviation measures the typical distance observations are from the mean. This measure takes into account the value of every observation. The units are the same units as the data, inches, centimeters, pounds, etc. Variance. So like I said, we will talk more about variance next semester. The variance is just the square of the standard deviation. This is not on your AP formula sheet. The units for the variance aren't particularly useful for us. Units are squared. The standard deviation is a much nicer unit. And again, we'll talk more about this next semester. We've talked a lot about resistance measures of center. What about spread? The interquartile range is a resistant measure of spread. The standard deviation is a non-resistant measure of spread. You should use the standard deviation as a measure of spread only when the mean is an appropriate measure of the center. The distribution of the data is fairly symmetric when you use that. When you have a skewed distribution, you should use the median as a measure of the center and the IQR as a measure of the spread.